Hello class, this is a video tutorial on multi-stage events. In this video we're going to be looking at probability tree diagrams. In some instances you may hear this be called a weighted tree diagram. Okay, so let's look at this scenario. A bag contains two red marbles and 3 blue bottles. A different bag contains 1 red, 1 blue and 2 green marbles, and a marble is selected from each bag. Okay, so let's take a look at a probability tree diagram to illustrate what this might look like. Okay, so here we go. Here's you see the little markings. It's good to sort of plan ahead what it might look like. Okay, so our first bag 1. Okay. Well, that is the only two things that can happen are red and blue. So I'm going to put that as red and blue. Okay. I'm going to leave the little branches open first. And the next one, the bag 2. A different bag contains 1 red, 1 blue, and 2 green. Okay, so 1 red, 1 blue, and 2 green. Right, and it's the same for the next branch going downwards, like so. And now we're going to draw in our branches in, like so. Of course, you can make this smaller so it fits your page, but I'm making it nice and large so you can fit it all in here. Okay, so but now here's where it changes from a regular tree diagram. Okay, we're going to include along the branches the probability of that particular outcome in that experiment. So by that we mean, well, the first bag has 2 red marbles, that's 2. Right? Out of a total of, well, there's 2 and 3 in the first bag, out of a total of 5, like that. So the probability of picking red in the first bag is 2 in 5. The probability of picking the blue marble, well, should add up to 5, so that's 3 in 5, like so. That's what that means, 3 in 5, there we go. And now we apply the exact same bit of logic, but with the second bag. So in the second bag we have 1 red, that's 1 red. What's the total of things in the second bag? That's 1, 2, and 2. That's a total of 4. Same goes with blue. There's 1 blue, the total of 4. In green, that's 2 green, the total of 4. Normally, you can simplify it, but when it comes to tree diagrams, it's best to keep it as the same probability without simplifying it. Well, we apply the exact same probabilities to each of the branches here. So that's 1 in 4, 1 in 4, 2 in 4. Okay. And now we'll just write down the results at the end. So this is red, 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 blue, red, green, blue, red, blue, 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 green. Right, there we go. So now let's calculate the probability of the following. Probability of red and then red. Okay, so the probability of red and then red. Now, here's where it differs once again to regular tree diagrams. Normally, we'd think of this as 6 possible outcomes. Okay, so 1, 2, 3, 4, 5, and 6. But because of these weightings on each of the branches, don't think of this as a total of 6 outcomes. Okay, we can find how many outcomes there are in total by multiplying the outcome. That's 5 and 4. So there are actually 20 different outcomes here. Right? Just the easiest way to remember this is if you want probability of red, we multiply the outcomes it took to get there. So red, that's 2 in 5 times 1 in 4. So that's a total of 2 in 20, which this final outcome we can simplify down to 1 in 10. So the probability of blue, green, so that's blue, green, well, probability of blue, green, that can be given as, remember, multiplying the branches it took to get there. So that's 3 in 5 times 2 in 4. So 3 in 5, 2 in 4. Multiplying the branches it took to get there. That's a total of 6 in 20, which we can simplify to 3 in 10. Okay. Last one, the probability of one red marble is at least selected. Okay, so we only want at least one red. So if you just take a look, this has one red. So there's this one, this one has 2 red. Okay, so really it's 1, 2, 3, and 4. Okay, now we can think of this as probability of blue-red plus, so we want this outcome plus the probability of this outcome, so that's probability of red-green plus red-blue and red-red. That's probability of red-blue plus the probability of red-red. Okay. Now I'm going to go through this very quickly, and I'm not going to show you my working out here. So blue-red, that's 3 in 5 times 1 in 4. That is 3 in 20. Red-green, so red-green, that's 2 in 5 times 2 in 4. That's 4 in 20 plus red-blue, 2 in 5 times 1 in 4. That's 2 in 20. And lastly, we've already calculated red-red. It's here. That's 2 in 20. And adding all these together, they all have the same denominator. That's 3 plus 4 plus another 4. Those two are 4. 3 and 4 make 7. That is 11 total out of 20. Hopefully that gave you an insight into probability tree diagrams. Best of luck.